Hi everyone, my name is Catherine. I am from SMA 1 IPA B and today I'm going to discuss about measurements, speed, velocity, and acceleration. So what is measurement? Measurement is a process of expressing the size or amount of a material or substance. For example, 25.6 kilogram. 25.6 is the value and then kilogram is the unit. So the value pertains to the amount and unit pertains to the physical quantity. Significant figures. Significant figures refers to the reliable digits plus the uncertain digits of the measured or calculated quantities. And here are some guidelines in determining the number of significant figures. Number 1. All non-zero digits are significant. For example, 34,529 miles. 3, 4, 5, 2, and 9 here are all significant numbers. So there are a total of 5 significant figures for these examples. And then number 2, zeros after the last non-zero digits are not significant. For example, 120,000 centimeters. 1 and 2 here are significant numbers. So there are a total of 2 significant figures for this example. Number 3. Zeros between significant numbers are significant. For example, 500,070, 5000, and 7 here are all the significant numbers. So there are a total of 5 significant figures for this example. Number 4. For numbers greater than or equal to 1, zeros at the right of the decimal point are significant. For example, example number 1. 1.0 milli. So 1 and 0 are both significant numbers. So there are a total of 2 significant figure here. And then example number 2, 200500 are all significant numbers, the same like example number 1. So there are a total of 6 significant figures for example number 2. Number 5. For numbers less than 1, 0 before the first non-zero digit are not significant while the rest are significant. Example, 0.00050036 centimeter. So starting from number 5 to 6, these are all the significant numbers. So there are a total of 6 significant figures in this example. And then number 6, for numbers that are expressed in the form m times n raised to n, all of the above rules are only applicable to the coefficient m. So example, 2.00 times 10 raised to negative 23. 2 and 0 here are the significant numbers. So there are a total of 3 significant figures for this example. Next, classifying system of units. So there are 3 systems. First, MKS system. Second, CGS system. Third, FPS system. MKS system stands for meter, kilogram, and second. CGS system stands for centimeter, grams, and second. And then FPS system stands for food, pound, and second. And this is the table of the 3 systems. Next, this is the table of classifying system of units, and this will be very useful for the topics that I will be discussing later on. So this is some examples of significant figures. Number 1, convert 2.36 kilometers to feet. So 1 kilometer is equal to 1,000 meter. And then 1 meter is equal to 3.28 feet. So what we're going to do is first, we multiply 2.36 kilometer to 1,000 meter over 1 kilometer. and then we multiply it again to 3.28 feet over 1 meter. So now we cross the same unit, kilometer and kilometer, meter and meter, and then we multiply the numbers 7,740.8 feet. So this is the answer. The next question, convert 27.5 horsepower to feet lbs. So HP here is a horsepower, and 1 horsepower is equal to 746 watt. So what you're going to do is you multiply 27.5 times 746. Press it on your calculator and you will get 20.515 watt or 20.515 kilogram meter square over second raised to 3. So 1 watt is actually equal to 1 kilogram meter square over the second raised to 3, so it's actually the same. And since the questions want to convert to feet lbs, so we use FPS system for this question. So what you're going to do is multiply 20.515 kilogram meter square multiply to 1 slug over 14.59 kilogram, and then 3.28 feet, 1 meter, and then multiply it to second raised to 2. And then cross the same unit, so kilogram and then kilogram, meter and meter, and then second. So now count the number. So multiply 20.515 to 3.28 times 3.28, and then you can use your calculator for this, and you'll get 220.708576 over 14.59. Count again using your calculator and you will get 15.12739 slug feet square per second. So now this is the answer for question number 2. Move on, I'm going to discuss about speed, velocity, and acceleration. So what is speed, velocity, and acceleration? Speed is the rate of change in motion. Velocity refers to the speed of a body at a given direction, and then acceleration is the rate of change in velocity. In speed, there is average speed. Average speed is the total distance traveled over the total time taken, and the pictures shown here are the formula of average speed. In speed, there is also instantaneous speed. Instantaneous speed refers to the speed of a body at a given instant, and the picture shown here is the formula of instantaneous speed. Next, there are 3 types of acceleration. First, positive acceleration, which means the velocity is increasing. Second, negative acceleration, which means the velocity is decreasing. And then number 3, zero acceleration, which means the velocity is held constant. And then this is the graph of positive acceleration. And this is the graph of negative acceleration. And the graph of zero acceleration. So here are the examples of speed, velocity, and acceleration question. Number 1. A car travels 120 km due north in 2 hours and 100 km due west in 1.5 hours. Question A. What is the average speed of the car in MKS and in FPS? Question B. What is the average velocity of the car in MKS? So, we got the given here. And for question number A, we need to find average speed. So, what you're going to do first is you need to write the formula of average speed. So the formula of average speed is sigma s over sigma t. So this means that you need to add s1 or speed 1 to speed 2. 120 plus 100 is equal to 220, and then T1 plus T2, 2 plus 1.5 is equal to 3.5, and then divide this, and you'll get 63 km per hour. And then, since the questions want us to convert this in MTS and in FPS, so we are going to use the same method like we did in the significant figure before. So first, multiply 63 km per hour to 1,000 kilometer 1,000 meter over 1 kilometer, and then multiply it again to 1 hour over 3,600 seconds, and then cross the same unit, kilometer and kilometer, hour and hour, and then when you multiply and divide all of these numbers, you will get 18 meter per second. So this is the answer in MKS. And then in FPS, you need to multiply 63 km per hour to 1,000 meter per 1 meter. 1 hour for 3,600 seconds, and then multiply it again to 3.28 feet over 1 meter, and then cross the same unit, kilometer and kilometer, hour and hour, and then meter and meter. Solve this with your calculator, and then you will get 57.4 feet per second. So this is the answer in FPS. And now let's answer question B. So what is the average velocity of the car in MKS? To find this, you need to use this formula. And then just now S1 is 120, and then T1 is 2. And then we divided 120 divided to 2, it's equal to 60 km per hour north. And then find the second average velocity. So 100 divided by 1 point divided to 1.5. and you will get 67 kilometers per hour west. Now, to find the average velocity of the car in MKS, you need to find the magnitude and the direction first. So, the formula to find magnitude is now we put 60 squared plus 67 squared. Use your calculator and you will get 90 kilometers per hour. And then to find direction, we use tan. So 67 over 60. And then move the tan from left to right. So now it's equal to 48 degrees. So the average velocity of the car in MKS is 90 kilometers per hour. And then 48 degrees west of north. So this is the answer to question B. So that's it guys for today's meeting. Thank you for listening.